The sun is the nearest star, a glowing sphere of gas, shining because of its heat, like a red-hot poker. The surface we see in ordinary visible light is at 6,000 degrees centigrade, but in its hidden interior, in the nuclear furnace where sunlight is ultimately generated, its temperature is 20 million degrees. All this churning power is driven by the sun's interior, which is converting 400 million tons of hydrogen into helium every second. The sun is a great fusion reactor into which 1 million Earths would fit. Luckily for us, it's safely placed 150 million kilometers away. It is the destiny of stars to collapse. But on their ways to their separate fates, all stars experience a premonition of death. Before the final gravitational collapse, the star shudders, briefly swells into some grotesque parody of itself. With its last gasp, it becomes a red giant. Some 5 billion years from now, there will be a last perfect day on Earth. Then, the sun will slowly change, and the Earth will die. There is only so much hydrogen fuel in the sun. When it's almost all converted to helium, the solar interior will continue its original collapse. The higher temperatures in its core will make the outside of the sun expand, and the Earth will become slowly warmer. Eventually, life will be extinguished, the oceans will evaporate and boil, and our atmosphere will gush away to space. The sun will become a bloated red giant star, filling the sky, enveloping and devouring the planets Mercury and Venus, and probably the Earth as well. The inner solar system will reside inside the sun. But perhaps by then, our descendants will have ventured somewhere else. In its final agonies, the sun will slowly pulsate. By then, its core will have become so hot that it temporarily converts helium into carbon. The ash from today's nuclear fusion will become the fuel to power the sun near the end of its life, in its red giant stage. Then the sun will lose great shells of its outer atmosphere to space, filling the solar system with eerily glowing gas, the ghost of a star, outward bound. Perhaps half the mass of the sun will be lost in this way. Viewed from elsewhere, our system will then resemble the Ring Nebula in Lyra, the atmosphere of the sun expanding outward like a soap bubble. And at the very center will be a white dwarf, the hot, exposed core of the sun, its nuclear fuel now exhausted, slowly cooling to become a cold, dead star. Such is the life of an ordinary star, born in a gas cloud, maturing as a yellow sun, decaying as a red giant, and dying as a white dwarf enveloped in its shroud of gas. The cosmos was originally all hydrogen and helium. Heavier elements were made in red giants and in supernovas, and then blown off to space, where they were available for subsequent generations of stars and planets. Our sun is probably a third-generation star. Except for hydrogen and helium, every atom in the sun and the Earth was synthesized in other stars. The silicon in the rocks, the oxygen in the air, the carbon in our DNA, the gold in our banks, the uranium in our arsenals were all made thousands of light years away and billions of years ago. Our planet, our society, and we ourselves are built of star stuff. The lives and deaths of the stars seem impossibly remote from human experience, and yet we're related in the most intimate way to their life cycles. The very matter that makes us up was generated long ago and far away in red giant stars. A blade of grass, as Walt Whitman said, is the journey work of the stars. The formation of the solar system may have been triggered by a nearby supernova explosion. After the sun turned on, its ultraviolet light poured into our atmosphere, its warmth generated lightning, and these energy sources sparked the origin of life. Plants harvest sunlight, converting solar into chemical energy. We and the other animals are parasites on the plants, so we are, all of us, solar-powered. The evolution of life is driven by mutations. They're caused partly by natural radioactivity and cosmic rays, but they are both generated in the spectacular deaths of massive stars thousands of light years distant. Think of the sun's heat on your upturned face on a cloudless summer's day. From 150 million kilometers away, we recognize its power. What would we feel on its seething, self-luminous surface, or immersed in its heart of nuclear fire? And yet, the sun is an ordinary, even a mediocre star. Our ancestors worshipped the sun, and they were far from foolish. It makes good sense to revere the sun and the stars, because we are their children. We have witnessed the life cycles of the stars. They are born, they mature, and then they die. As time goes on, there are more white dwarfs, more neutron stars, more black holes. The remains of the stars accumulate as the eons pass. But interstellar space also becomes progressively enriched in heavy elements, out of which form new generations of stars and planets, life and intelligence. The events in one star can influence a world halfway across the galaxy and 1 billion years in the future. Surrounding the Milky Way is a halo of matter, which includes the globular clusters, each containing up to 1 million elderly stars. At the centers of globular clusters and at the core of the galaxy, there may be massive black holes ticking and purring, the subject of future exploration. We on Earth marvel, and rightly so, at the daily return of our single sun. But from a planet orbiting a star in a distant globular cluster, a still more glorious dawn awaits. Not a sunrise, but a galaxy rise, a morning filled with 400 billion suns, the rising of the Milky Way. An enormous spiral form with collapsing gas clouds, condensing planetary systems, luminous supergiants, stable middle-aged stars, red giants, white dwarfs, planetary nebulas, supernovas, neutron stars, pulsars, black holes, and, there is every reason to think, other exotic objects that we have not yet discovered. From such a world, high above the disk of the Milky Way, it would be clear, as it is beginning to be clear on our world, that we are made by the atoms and the stars, that our matter and our form are determined by the cosmos of which we are a part.